moving on to Wi-Fi, right? Just a brief introduction of what this presentation is going to be. I'm going to go through the history of wireless networks, wireless local area networks, the different protocols that are available out there from when they started all the way up until today, security, and also like how to secure your personal networks at home and at office, and also how to extend the range and increase the speed of your wireless networks at your home without spending a lot of money and just doing a few tweaks and things that can help improve performance. And finally, I'm going to end up talking about a little tool called DDWRT, which is a router firmware, but we'll get to that later on. So moving on, the history and protocols, right? So the 802.11 standard, which is what wireless networks are basically all about, like the standard as it's formally known is 802.11. It first kind of got born in 1985 when the US FCC allocated the 2.4 gigahertz frequency range for public use, for free use, without it needing to be licensed, right? But it didn't reach the consumers at that point. At that point, it was used for some, like, the grandfather of RFID. You know, that was the first, product tracking at supermarket cashiers. That was like the first application of 802.11. But then right around 97, 802.11 was released to the general public. It was commercialized for the general public. And that's when people could first start using it at their homes and offices. And then in 1999, 802.11a was first released, and that's when it started being more accepted into the market. The 802.11a standard had a range of about 35 meters indoors, 120 meters outdoors, and could go up to 54 Mbps. But realistically, you got more like 20 Mbps. And it worked on a higher frequency range, which is a 5 gigahertz range. So the higher frequency meant that it couldn't travel as far as the ones that we use now. So then they released 802.11b, which was also right around the end of 99. But the products first started appearing in 2000. I think that's when, like, the B standard is when products first started hitting Sri Lanka, like to the mass market, even though those days it was very, very expensive to get a wireless access point or a wireless router, especially because of TRC clearance issues and whatnot. But it had a range of about 38 meters indoors, 140 meters outdoors, and it could go up to 11 Mbps. But as the signal degrades, it steps down as low as 5 Mbps. The reason why the B standard is actually slower than the A standard is because they wanted to allow it to reach further than what the A could. The A could really not go through one wall. As soon as it went through one concrete wall, you get 0 signal strength. But so then they released the B, which ran slow, but it could cover a larger distance. And one big problem that both the B standard and the G standard that came next suffered was it picked up a lot of interference from all these other 2.4 gigahertz devices like cordless phones, security systems, car alarms. I remember I had a B router and a cordless phone, and whenever I answered a call on my cordless phone, my internet connection would drop. So it was a common problem, right? And that problem carried on to the G standard as well, which is probably what you're all most familiar with. Most of you, if you have a wireless network at home, it's probably a 802.11g router or access point, right? It was ratified in 2003, but products actually started coming into the market before the actual standard was ratified. It also had a range of 38 meters indoors, 140 outdoors. And by the way, these are like more realistic ranges. So when you think about wireless G, when you look at the box, it says 150 meter range. That's like in ideal lab conditions. You can't realistically hope to put one router in the middle of your house and cover the entire house because it has a 150 meter range, right? Practically indoors, you're looking at about 38 meters, but that's also during, like, with very good conditions. Realistically, it could be less than that. The G standard was completely backwards compatible with the B standard. So if you had a a B access point or router and you had a G wireless card, it would still work, and also vice versa. And the speed could go up to 54 Mbps, and that would also step down as low as 5 Mbps if the signal strength was not good enough. And like I said, it also suffered interference from other 2.4 gigahertz devices like cordless phones and things like that. The reason why they came out with the G standard was because they wanted to have the same reach as the B standard, but with a higher speed. So what's out there now is 802.11n, and it first came out as a draft. It wasn't formalized until recently, but the N standard started being adopted in 2007, and it can go up to 150 Mbps because it uses a thing called MIMO, which is multiple input, multiple output technology. If you look at any of the N devices, they have two antennas, and both antennas transmit and receive at the same time, and that allows for faster speeds, and it also allows for better error correction. So when both antennas are transmitting the same data stream, and there's two antennas at the other end receiving the same data stream, when it compares the two, it can find errors very quickly and correct them, instead of having to send the packets back and forth again until you get the correct packet. But then finally, the N standard was ratified in 2009, and the final N spec can reach up to 70 meters indoor, 250 meters outdoor, and can go up to 300 Mbps, and it uses both the 2.4 gigahertz range and the 5 gigahertz range, so it's less susceptible to interference from other devices. All right, so enough about the background and the history of it, right? Moving on to wireless security, this is probably the most important. If you don't listen to anything that I say, just listen to this part of it, right? Which is wireless security. The first thing is WEP, which is wired equivalent privacy, right? That's what that means, and it is the biggest lie that you will ever have been told, because there is absolutely no privacy in WEP. If you have a wireless network at home or at your office and you use WEP as an encryption standard, you may as well just save the time of not using it, not having to enter the key, because it can be cracked. It was the first wireless security standard, right? So understandably, there are some flaws with it. There are actually a lot of flaws in it. It can be cracked in under 5 minutes. Right now, the world record is 2 minutes and 55 seconds for cracking a web network, right? But you can crack it like this, and all the tools that you need to crack it are freely available. There's AirSnort, AirCrack, OftCrack, all of those you can just freely download as an ISO on a CD, as a live ISO on a CD. You boot it up in any laptop, and then you can use that to crack web keys, just plug and play, right? But there is an advantage of web, which is that it works best with most old equipment and software. If you have Windows XP and you don't have Service Pack 2, or you don't have at least Service Pack 2 installed, then any of the newer security standards won't work. So, you know, some people feel forced into using web because they feel that it provides the most compatibility, but don't. Upgrade, because there's absolutely no point in having, you know, it's like having a door lock but leaving the key in the door. There's no point in it, right? The two security standards which are more widely adopted nowadays and used nowadays are WPA and WPA2, right? These two security standards are uncrackable for now, as long as you use a strong passphrase. If you use a passphrase that is 8 characters or less and is a dictionary word, it can be cracked in under a minute. If you're using WPA or WPA2, make sure that you have a 14 to 15 character passphrase or a pre-shared key, a PSK, right? And make sure that you have it at least 14 or 15 characters long. Make sure you have capitals, numbers, and special characters. And if you do, that security is, as of right now, it's uncrackable. All right? People have tried and they've gotten a certain way, but they haven't still fully cracked one. But these two both, you know, what my company does is we set up secure wireless networks for clients, right? That's one of the things that we do. And whenever we set up WPA or WPA2 older iPods, iPod Shuffle, like the first iterations of the iPod Touch, those devices don't work. And it's a trade-off between security and accessibility. Do you really want, it might be the CEO of the company that has an iPhone, but he might not be able to get onto your corporate network because the iPhone can't support WPA. So you have to be very careful as to how you go about it. Alternatively, security, it needs to think on its own, right? Nothing says security like Dirty Harry, but the best security measures that I can recommend to you from a professional standpoint, right, is to have a multi-tiered security level for your wireless network. Now, I'm not saying that everyone should do this. Not everyone's wireless network needs to be, Fort Knox. You probably don't have that much data on your machines that you really need to protect that critically. But if you're ever in a situation where you do need to protect, you have very sensitive data, and you need it to be airtight, rock solid, my recommendation to you is to have WPA2 security, right? Start off with that as your baseline and have a pre-shared key, a nice long pre-shared key, and set that up for your encryption. Then set up MAC address filtering on all your access points or routers. What you can do is you can, every networking device has what's called a MAC address, and that address is unique to that particular device anywhere in the world, right? You can add that to a list saying only these devices are allowed to connect to this particular access point or this particular router, right? Now, after you do those two things, say someone steals a laptop, right? That's already, someone steals my laptop and they go into my office and they try to log into my wireless network, right? They already have a machine that's on the MAC address list, and they already have the next step that you should put is to have a separate VPN network within your wireless network. And the way that that works is your access point with all your remote devices connecting to it, right? And before it reaches your local network, before it reaches your main corporate network, is to have another firewall. So even if someone gets on here, connects to the wireless network, they can't get into here without going through this VPN server. And for that, you need to have another username and password, right? This is how we set it up for most corporates, because what happens is they'll want free wireless access for their roving reps, like for their, not their roving reps, but their international suppliers. International suppliers will come into an office and they'll say, hey, can we use your internet to check our email or whatever? At that point, you can't really say no to someone who's a supplier or a business partner, right? So what they do is they keep their wireless relatively open. They just have a very basic encryption, very basic password, and then they just allow people to access the wireless through that. Whoever needs to access the corporate network, like actual roving employees and roving salesmen, have a special username and password that lets them log in to their local network. That is, as far as I'm concerned, probably the most, it's the tightest form of security that's out there. And it's something for you guys to keep in mind if you ever do need to set up a secure network, or call me and pay me a lot of money to set it up for you. That's also a good option. But basically, multiple levels of security means multiple barriers that someone who's trying to break into your network has to get through. And that's the key thing, is to not make it easy for people to get in. Moving on to the next bit, which is also quite relevant to everyone. Can anyone see these graphs? No, they're too dark. All right, cleaning up your signals and making them stronger. So when you're using a wireless network, it operates on a distinct channel, right? Channels range from 1 through 14, right? And you can select that. 14 actually is only for Japanese use. So unless you have, channel number 14 is only used in Japan. So unless you have a router that someone brought down for you from Japan, you're probably not going to see channel number 14. You'll see 1 through 11, right? And basically what you can do is you can pick whichever channel that you want your network to operate on. It's right there in the wireless settings. Every router is different, but it's right there. You can pick what channel to operate on. So on all of those channels, there are actually only 3 clean channels: channel number 1, channel number 6, and channel number 11. And channel number 14 if you have that option, but I'm just going to ignore that for now. So as much as possible, try and do a signal survey of your home or your office, right? There's a great free tool called XIRUS, that's XIRRUS, Wi-Fi Inspector, that you can download. It's free. It runs on Windows. Just like that, there's so many tools out there where you can basically do a survey. Now, these pictures were taken on my tab. For Android, there's like hundreds of programs. If you just go to the store and search for Wi-Fi Analyzer, there's hundreds out there, right? And it'll actually show you which channels have networks on them. So this was just done at my home. And ideally, what you want to do is you want to be on a channel that's like less noisy. So in this kind of situation now at home, I know that if I want to set up another Wi-Fi network for personal use or for my family's use, channel number 1 is probably the best bet because there's nothing there. At the moment, there's already 3 networks operating on channel number 6 and channel number 11. Cleaning up your network, like say if you do a Wi-Fi survey and your neighbor's got something on channel number 6 and the other neighbor's got something on channel number 11 and someone else has something on 7, pick the cleanest one possible. And don't quote me on this, it's very wrong to do this, but if your neighbors have left unsecured wireless networks, just move them out of the way so you can create a clean network for yourself. Don't go in and do anything malicious to their network, but change the channels so that you can create a clean, nice little slot for yourself. Doing that will actually also improve the range of your wireless networks. So it's quite common, like when we do setups in offices and stuff, the IT department will want to have their own little wireless network and then have us set up a network for general use, where we have to tell the IT department, okay, you can only use these channels so that we can get a better signal throughput throughout the rest of the facility. That's, just clear out the spectrum as much as possible so that you have your one channel. Moving on. Another thing that you can do at home, probably not a good idea to do this at office because it's going to look really silly and your boss is going to ask you what's going on. But you can build this thing called a windsurf antenna, right? It's really simple, right? It's a homemade antenna. You can download this template. Just Google windsurfer. I'll tell you from experience, it does work. It makes your wireless signal more directional. It won't spread all around. But if you have the option of putting your router or access point in the corner of a room and then focusing the signal in one direction, then this works really, really well. So all you do is you cut out the template, you put tin foil on it, paste it all together, stick it on top of your antenna. I found, I did some testing in an open area, and I found that using this, I could go up to 50 meters further, where I had signal reach for more than 50 meters further than without it during testing, and that was in an open area. So just Google windsurfer, and it's right there. I'll also be putting this presentation up online, so anyone can just go through it. I'll be tweeting about it, so anyone that follows me on Twitter, you'll be able to get the link, and I'm sure Nazli will be able to put it on the Refresh group as well. So moving on, the last thing that I want to talk to you guys about is this tool called DDWRT, right? It's a free custom firmware for your router or access point. It doesn't work on every router or access point. On their website, if you search for DDWRT, they'll have a hardware compatibility list. Just make sure that your router or access point is on there. And install this. Once you do, you can do a lot of things with it. Far more things than what your router is capable of out of the box, right? One of the biggest things is that you can build a wireless distribution system. So if you are in the position where you need to set up a wireless network in your home or an office over 5 stories or 6 stories, or forget about stories, even over just a very large area, right? You can use DDWRT and a wireless distribution system. And what you can do is, without having copper lines in between your different access points, you can just have the different access points as repeater points. And basically, the signal will travel from one access point to another, to another, to another, to reach the end user. And it will actually, when you set it up properly, even if one access point goes down, the next one in the line will still be able to pick up the signal from somewhere else and still keep the network pretty much contiguous, right? So that's one of the things that you can do with it. You can also use multiple devices as universal repeaters, which is basically if you go to buy an access point that has a universal repeater feature, unless you go for something that's really low-end and Chinese, it'll cost you about 11,000 to 15,000 rupees. But for 5,600 rupees, you can buy a router that supports DDWRT and put it on, and you can use it as a universal repeater wherever you need to have a signal boosted, or you have a device that is a wired device that doesn't have a wire to it. You can just put a router there and connect the wire between the router and that device, and it'll work on the same network. So kind of like using it as a wireless bridge, or using it as a repeater for, like, say there's a very weak signal in this room, just put up a router in here and it'll repeat it for everyone in this room to use. You can also, using this software, set up Wi-Fi hotspots, which is, if you go to, like, say, Cinnamon Grand for an example, you pick up about 5 different wireless networks and they're all open. So you're all happy, oh yeah, free Wi-Fi. You click on it and you try to connect, and all of a sudden, as soon as you load up your browser, you get this page asking you for your room number or a voucher code, right? Those systems are very, very expensive to set up normally. But using DDWRT, there are a few other free open source hotspot software like Wi-Fi Dog, Chili Spot. Those are the only 2 free ones, actually, Wi-Fi Dog and Chili Spot. Using those 2, you can basically set up that kind of authentication system. And by doing that, you can actually monetize your free Wi-Fi. So if you have a coffee shop or a restaurant or so on, sure, go ahead, offer free Wi-Fi. But every time that someone wants to use it, ask them to enter their email address and then put up a splash page about today's special, right? So that way you build up your email marketing database, and you have, you're advertising your specials or whatever. Alternatively, you can charge people to use it as well. That kind of thing can be set up as well. Once again, if you're interested in, if any of you guys have companies that are interested in doing that sort of thing, please do get in touch with me, because that's also something that we do offer as a professional service. So that about wraps it up. Gone to about 25 minutes, sorry, Nazli. So that about wraps it up. I am open to any questions, and during the question time, I'm just going to put up my About Me page. It's about.me/THAR, Tha. All the ways that you can contact me are on here, right? My Twitter, my Facebook, my LinkedIn, and my Google+. Taking a page out of Amita's book, I don't accept any friend requests on Facebook unless I know you personally. Even on LinkedIn, I think from last month, Refresh, someone added me and I was like, who are you? Do I know you? But Twitter is probably the best way to get a hold of me, because my timeline is public, and anyone can DM me. All right, thank you very much, guys, for your attention.